Welcome to this explainer. Today, we're going to completely shatter a really common and honestly pretty dangerous illusion in software development. You know the one? The idea that a green checkmark in functional testing means you're totally ready for production? Nope. We're talking about load testing, finding those hidden bottlenecks, and why validating your performance is an absolute, non-negotiable responsibility for any cloud architect. Okay, so picture this nightmare scenario. Your team has just spent months building this highly anticipated app. It goes through rigorous QA. Every single button works perfectly. The workflows are totally flawless. Code is deployed, marketing fires off the massive launch email, and boom, 100,000 real users click the link at the exact same time. What happens next? Does the app gracefully handle the surge, or does it immediately crash, leaving your customers staring at error pages and your engineering team kind of questioning all their life choices? The harsh reality here is that dev and QA environments, yeah, they're great for checking functionality, but they almost never simulate the actual chaos of the real world. A system that works perfectly for one single tester can completely fall apart when you introduce resource contention, sudden traffic spikes, or database saturation. Basically, functionality just doesn't equal scalability. If you haven't tested your system under a heavy load, you literally have no idea how it's going to behave out in the wild. Okay, let's dive into this. We'll be hitting 1. The production reality check. 2. What is load testing? 3. Load versus stress testing. 4. Uncovering hidden cloud bottlenecks. 5. Best practices and tools. And finally, 6. Designing resilient cloud architectures. Section 1. The production reality check. Let's expose the major blind spots in traditional software delivery. So, what exactly is the goal here? Well, load testing is essentially evaluating how your platform performs under expected levels of user activity so you can find those hidden bottlenecks before your customers do. Notice the word expected there. The primary goal isn't actually to break the system. It's to check response times, throughput, resource utilization, and overall stability. It answers the fundamental architectural question. Can this platform actually handle our expected demand while still hitting our business SLAs? Section 2. What is load testing? Let's quickly establish why this is a core architectural responsibility and not just a box to check. Moving right along to Section 3, load versus stress testing. Let's clear up some industry terminology that gets mixed up all the time. Now, what's really interesting about this slide is how clearly it separates the two. On the left, load testing evaluates your system under expected workloads. It asks, can we support our target of 10,000 concurrent users? Are our response times okay? Does auto-scaling actually kick in? But then look at stress testing on the right. That's where you intentionally push the platform way beyond its expected capacity to see what snaps first. How does it fail? Does it fail gracefully? Does it recover? They're both super important, but they answer totally different questions about your architecture. Section 4, uncovering hidden cloud bottlenecks. This is where it gets really fascinating, because modern cloud elasticity, it's amazing, but it does not magically make system limits disappear. Let's walk through a real-world scenario to see how this plays out. Imagine a major e-commerce setup hosted on Google Cloud. On paper, it looks bulletproof. You've got a global external application load balancer routing traffic to a fleet of containerized apps running on Cloud Run. For data, it uses Cloud SQL as the primary database, plus memory store, which is basically Redis, for caching, and it's all watched over by cloud monitoring. It's built to auto-scale, right? Seems ready for absolutely anything. But then, marketing drops the promo codes for a massive flash sale. Instantly, 50,000 concurrent users blast the architecture. Let's look at the results of that load test. The compute layer? Totally flawless. Cloud Run scaled out automatically, just like it was supposed to. CPU utilization stayed perfectly fine. But the users? Yeah, they are seeing error pages. Why? Because even though the application scaled up, Cloud SQL hit its absolute maximum connection limit. The database completely saturated. The compute wasn't the problem at all. The database was the hidden bottleneck. And without a load test, this catastrophic failure would have happened during a live, revenue-generating sales event. And this brilliantly illustrates a much wider truth. Whether you're on Google Cloud, Azure, or AWS, bottlenecks love to hide. You might hit Kubernetes resource limits or find out your autoscaler is way too slow to react to sudden spikes. Maybe third-party API rate limits suddenly throttle your entire app, or your network load balancers get saturated, causing massive latency, even when your servers are just sitting there idle. Or maybe you've even got an application-level memory leak. They are everywhere. Section 5, best practices and tools. Let's get you equipped with the right workflows to actually solve this. There are some really fantastic industry standard tools out there. K6 is incredibly popular right now. It's scriptable and super friendly for CI/CD pipelines. Apache JMeter is the mature giant in the room, supporting a massive amount of protocols. Locust is awesome and highly customizable if your team is into Python, and Gatling is fantastic for high-performance testing and detailed reporting. But honestly, the specific tool you pick is actually way less important than how you design your test scenarios. Unrealistic test scripts are just going to give you a false sense of security. To get real value here, you have to follow a few critical steps. First, simulate realistic user behavior and actual peak scenarios. Second, you can't just look at CPU. You must monitor absolutely everything: databases, APIs, network latency, the whole shebang. Third, validate those auto-scaling triggers so you know they actually fire on time. And fourth, this is a big one, integrate this testing into your CI/CD pipeline continuously. The biggest mistake organizations make is treating load testing as a one-and-done pre-production chore. It needs to be an ongoing process. This brings us to Section 6, Designing Resilient Cloud Architectures. Let's wrap up with the ultimate mindset shift. So the crucial point is this: load testing transforms your assumptions into hard, measurable evidence. Cloud-native platforms make scaling easier than ever, for sure, but they absolutely do not eliminate architectural bottlenecks. Your system isn't going to be judged by how functional it is on a developer's laptop. It's judged by how it performs, degrades gracefully, and recovers under actual real-world production demand. Because great architects, they don't just assume their systems will scale, they prove it. I want to leave you with this one vital question. When was the last time your production architecture was tested under realistic traffic conditions? If you're drawing a blank, or if the answer is never, you honestly don't know how your system is going to behave when it matters most. Don't wait for your biggest business day to discover your limits. Take these concepts, apply them to your cloud environments, and start validating your performance today. Thanks so much for joining me for this explainer.